Bismillahirrahmanirrahim. Welcome back to my channel. I've been boring you for last couple of videos regarding DES. So this is the last topic I want to conclude DES. The question that I need to ask myself that after DES, they just have a different version of DES, which is called triple DES. So first, let's look at triple DES. What triple DES is all about? Three DES. And then why not two DES? Why they jumped from DES to skipping to two DES and jumping towards triple DES? So as triple DES, as the name implies, you're doing actually data encryption standard three times. So in DES, in original DES, the key size was 56 bits, and due to actually faster and faster computers now, and if you were to just look at now the computers are so fast, we will be able to break that key in no time, because the key size was 2 raised to 56, which means nowadays computers are too fast and they will break that in no time. So they skip 2 DES. We're going to look at why. Let's look at why they have 3 DES. So 3 DES means you have 3 different keys. Exactly the same, every single procedure, round procedure is exactly the same. Based on individual keys, you're going to produce, based on those individual master keys, you're going to produce individual 16 different round keys, and so forth and so on. In triple DES, you have 3 different unique keys. So you will have key 1, key 2, key 3. These keys are going to be your master keys. So what are you going to do with these keys? The first process that you're going to do is this. You're going to take your key number 3, you're going to encrypt you. So you're going to take your message, you're going to encrypt that using key number 3. This key number 3 is going to be your master key, and based on that master key, you're going to run 16 rounds, and those 16 rounds will have 16 individual keys based on K3. After you do that, after you encrypt your data using K3, you're going to decrypt that data with K2. So since the key is not same, of course you're going to get some gibberish message. So the encryption, so after you have encrypted your key data with key K3, you're gonna decrypt your data with K2. All right, so you're gonna do a decryption process, decryption process using K2. Once you have decrypted your data, you're gonna encrypt your data with K1, which is going, and these keys are individual keys. These are 3 different keys, and based on these 3 different keys, you're gonna produce 16 different round keys for every single key. So how many rounds are going to be there? So if you have a single key, if you are doing a single DES, which means you are doing a single DES, you have 16 rounds. So the number of rounds are going to be 3 times 16. So the number of rounds will be 48 rounds. Right, and the key size is going to be 168 bits, because you have 56 bit for single DES. Now you have triple DES, you have 3 times 56, so your key size now has increased 168 bits. Hence your security has tremendously increased by 3 times what security that you were getting using DES. So the key size is going to be 3 times of a single DES, which is 168 bits, and number of rounds will tremendously increase. Now the number of rounds will be 3 times 16, which is going to be 48 rounds, which makes sense, because if a single key, we have 16 rounds, now we have 48 rounds. So that's why triple DES is much robust. Because you're encrypting it first with a different key, then you're decrypting it with a different key, and then at the end you're encrypting it again with a different key. Hence you're getting a security, and 168 bit, 2 raised to 168 bit, that's a very huge number. The kind of security that you get, but it's going to be 3 times slower than normal DES too. Of course, I'll show you from NIST website, you can still use that. So this is a valid protocol. So now let's come back here. What was double DES? If you were to look at double DES was simply means that you're using 2 keys. So triple DES means you're using 3 keys. The underlying protocol for triple DES, double DES is exactly the same as single DES. You will have exactly those file network where you are shifting it. You have expansion key and other things like that. But you're just increasing the number of keys. So the encryption is based on two keys on a message. So first thing you're going to do, you're going to encrypt your message with key 2. Then you're going to encrypt it again with key 1. All right. So you're encrypting your message twice, but with different keys. So the key size is going to be what? If you were to look at a key size, so key size is going to be 2 times 56 bits, because in original DES algorithm you have 56 bit of key. So 56 times 2 is 112. So 112 bits. All right. So now I need to answer this question, because this is an important question that I need to answer. Now, number of rounds. So I'm using double DES, which means if 16 rounds are required for single DES, for double DES is going to be 2 times 16. So number of rounds, or 2 times 16, which is going to be 32 rounds. All right. Number of rounds. So why not 2 DES? Now the question is, why not 2 DES? All right, so let's just quickly look at it. Let's take a ratio. So let's say you start doing a brute force attack, and you start doing a brute force attack. So let's take a ratio between your double DES and triple DES. If you were to look at it, double DES, which is this. So I'm taking a ratio of the key size of both of these DES. So double DES is 2 raised to 112 bits divided by 2 raised to 56 bits. So basically I'm taking a ratio between double DES and triple DES. Now if I were to just rewrite this equation as this, I can rewrite this as this: 2 raised to 56, 2 raised to 56. When the bases are same, you can just simply add powers, divided by 2 raised to 56. Now when I take a ratio of this and this will cancel out, and your security is exactly the same thing, approximately, or exactly the same thing as 2 raised to 56. So that's why you don't want to use double DES. I hope you're getting it. Now if I were to apply exactly the same logic here on triple DES, so triple DES is 2 raised to 168 bits divided by 2 raised to 56. All right. Now using the same logic, so 2 raised to 56 times 2 raised to 56 times 2 raised to 56 divided by 2 raised to 56, just simply taking a ratio from triple DES to 1, as compared to, because it's just comparing the ratio, taking the ratio between these two. Now this and this will cancel out. You will still end up with a security level of 2 raised to 112 bits, approximately equals to or slightly greater than this. So 2 raised to 112 bits. Even though you're using triple DES, you're getting a security level up to 2 raised to 112 bits. Why not double DES? Because if you were to take a ratio from double DES to single DES, this is just like having a security level or a brute force attack time. The time it takes for you to do a brute force attack is exactly the same thing as your single DES. So that's the reason you want to avoid. I just want to show you something real quick. Triple DES is still being used. So I'm going to bring in my laptop. Just give me a minute. All right, let's look at it. So this is a website by NIST. If you want to closely look at it, this is a NIST website. This is the website that actually define the standard in terms of cryptography and things like that. If you want to quickly look at the website, what are some of the approved algorithms? So let's just quickly look at it. Currently, there are 2 approved block cipher that can be used for both applying cryptographic protection and removing or verifying the protection that was previously applied. First one is AES, which I made a huge, the entire video on AES, how you encrypt or using AES. The second is triple DES. So triple DES is being used, while 2 are disapproved, which were previously approved, were DES and Slipjack. However, their approval has been withdrawn. This is from an official website by NIST. All right, you can clearly see AES is a dominant protocol, and triple DES is still being used, and it is being approved protocol. You can still use it as a block cipher, but no one uses it. AES is the most common website, but common symmetric key algorithm. You can still use it, but it's up to you. Now, I just want to show you something else too. I was just trying to just capture some packets where I can actually see on a Cipher exchange. You can see triple des, but I was unable to capture up any packet that has triple des in it. So I hope you like this small tutorial on why not double des. If you have any questions, leave it in the comment section, and don't forget to like and subscribe to my channel.